Welcome to THREELINE INFOTECH. Okay, today I am going to explain about DataPower cryptographic tools. Okay, how we are going to implement cryptographic tools in our DataPower. Okay, so how we are going to make use of like cryptographic mechanism in DataPower. So cryptographic is like DataPower has powerful cryptographic capabilities. Like if you take any cryptography, okay, so in general, like in many technologies, not only in DataPower, like if you take already existing technologies like any Java, C, so there also we can make use of cryptography. Okay, same way like in DataPower also we can use of cryptography. Okay, so like what is the need of using cryptography? So it has three fundamentals. Okay, if you take any cryptography concept, so generally we use for these three things: confidentiality, integrity, and non-repudiation. So these are the three things like why we are going for the cryptography. So if I say confidentiality, just I want to ensure that no one other can see my message. Okay, so just I am sending to the my third party system. Okay, so I want to make sure like only that person is seeing my particular message. No one is able to see that message. Okay, that comes under confidentiality. Okay, so if I say integrity, so no one is intercepted or no one is changing my data. So I want to make sure that like so my client is sending my message to server. Okay, I want to make sure no one is tampering my message, no one is changing my message. So that's why that comes under the cryptographic tools. So it's a non-repudiation. Okay, this is also like one of the feature of the cryptography. So by using this, I can make sure that no one is like no one other. Okay, it's communicating with whom I am expecting. Okay, so just I'm consider like I want to send to the particular server. Okay, so like by this cryptography, so I can make sure that right I'm sending to the proper particular server. Okay, these are the different features of the cryptography. Why we are going for the cryptography? Again, like cryptography is a separate topic. So just I am going to explain like how we are going to make use of that existing cryptography into DataPower. Okay, like if you take cryptography in general, it contains some keys and certificates and signatures and digits. So these are the things mainly. Okay, keys and certificates, signatures and digits are the parts of the like cryptography. Okay, again cryptography contains two types of encryption. There is symmetric key encryption and asymmetric key encryption. Okay, so these are the two different types of encryption of the cryptography. So as explained, right, cryptography is a combination of keys and certificates. Okay, signature and digits. Okay, same way like so if you take different type of encryption, symmetric key encryption and asymmetric key encryption. Okay, I'll come back to here. So if you see this flow diagram, so you can see two things here: symmetric key encryption and asymmetric key encryption. Okay, so cryptography contains keys and certificates. If I use same key, okay, so my scenario is like instead of sending plain message, okay, so I'll send a message to the server. So instead of sending a message directly, so what I'm going to do, right? So I will take the incoming request, I'll apply some key to that one. So I'm going to encrypt that particular message and I'm going to send back to the server. In server, I'm going to use some other key to decrypt that one. So that's how cryptography is going to work. Okay, I'm going to use some keys. Instead of sending the direct message, I'm going to encrypt the message and I'm going to forward that one. Okay, so in that we have two types of encryption: symmetric key encryption and asymmetric key encryption. If you take symmetric key encryption, I am going to use same key. Okay, so if you see this one, right, here is a text, this is the incoming message. So this is the encryption, this is the encrypt key. I am going to apply some key for that one. So generally in key means it contains some algorithm. Okay, key cryptography again is a different topic, if you use topic. So it contains keys and certificates. Okay, contains keys and certificates. So it will take the incoming message and it's going to apply this particular key to that one. So then we are going to get some ciphertext. Ciphertext means the encrypted data. Okay, then I am going to apply. This is the client side. Okay, this is the client side. What you are saying is the client side. In server side, okay, so I am going to use one more key to decrypt that one. Okay, so what is the difference between symmetric and asymmetric, right? So if you use same key to encrypt and decrypt, then we can say the symmetric key encryption. If I use two different keys, like I am going to use one key for the encrypting message and I am going to use one more key to decrypting the message. So I will say the asymmetric key encryption. Okay, it has the features of so if you see this one, right? Okay, symmetric key encryption. Same key is used to encrypt and decrypt. Okay, it has advantages and disadvantages. Advantages are like fastest because since we are using same key to encrypt and decrypt, okay, so it's a very fast, okay, and it will take very less CPU resources. But disadvantage is since we are using same key, consider like when cryptography comes into picture, right? So we have one client, we have a server. Consider client is some Java client, and we have some server as a DataPower server. So instead of interact, so just you want to interact, just you want to send a message from Java client to the DataPower. Here DataPower acting as server, and Java client is the client. Okay, instead of sending a message directly to the server, so just we can do cryptography thing by using this mechanism, cryptography mechanism. So what I'm going to write. So instead of sending a plain message, I will take the client. While sending from the client, I will use some key, and I am going to encrypt that message. I am going to send to the DataPower. In DataPower, I am going to use one more key to decrypt that particular message, so that I can make sure no one is like changing my message. No one is like seen between a message. Okay, while sending from client to the server. So my message is like my message is good. No one is like modified at my message. So that's how we are going to confirm. So in that, like we have symmetric and asymmetric. So if I use both same keys in the client side and server side, then I will say it's a symmetric key encryption. If I use different keys, so generally in real time, like we are going to use a asymmetric key encryption. Okay, the key which we are using in the client side, we can say the public key, and the key which we are using in the server side is the private key. Okay, so I'll come back to the asymmetric key encryption. The two separate keys having mathematical relationship. Okay, so I already said like asymmetric key is going to use two different kind of keys. Correct. Okay, so one is client, one is server. So it has two different mathematical relationships. So if you like consider scenario, we have a client. Okay, so you have to use public key to encrypt your message. So you have to use corresponding private key. Okay, corresponding private key to decrypt the message. Like generally in we have so many tools. Okay, we have so many open source like IBM Key Manager is there, Open SSL there, DataPower is there to generate keys and certificates. So we can generate keys and certificates using by tools, those tools. Okay, so if you generate any certificates and keys from the tools, these kind of tools, you will get two things. One is public key and private key. So what I'm going to do, right? I'm going to share my public key with client. I'm going to store that particular private key, corresponding private key to DataPower. Okay, so then while sending, right? So client is going, so consider like you have 10 clients. So I'm going to share my public. So if you name itself, this is the public, right? So I'm going to share public key with 10 clients, and my private key is the private. Okay, so I'm going to keep into DataPower. So client who sends the public like message with the encryption message with that particular public key can decode it, like can decrypt it by using particular private key, which is present in the data port. Okay. So here advantages are like so security moves more. Thing is like if you take any symmetric, so in symmetric we are going to use same key, like same key for encrypting, same key for decrypting. Okay, but in asymmetric, right? So we are going to use two different and public and private key, so it is more secure. Anyhow, since we are using two different kind of keys, so it will take some higher CPU resources. Okay, so thing is, but it's a more secure. The key, like if you are sending a message with a public key, the corresponding private key hold only can see the message, can decrypt the message. Okay, so that's how we are going to implement cryptography in DataPower. So here we have so many concepts. Okay, by using this cryptography, you can implement many things like encryption, decryption, okay, sign and digital signature and verification. So everything like using this keys cryptography concept. See, if you see this flow, right? See, that's how like cryptography is going to work. Okay, so just consider simple sender and receiver. Okay, so sender will send an incoming message. So there I'm going to apply hash algorithm. So hash algorithm is a part of the key. So consider sender is a client, receiver is a server. So it is some Java client. This sender entire sender Java client. The receiver is a some DataPower service. Okay, DataPower server. So sender is while going to send us, right? So sender what he will do, right? So he will take the incoming message and he going to apply a public key for that one. So like internally this public key contains this hash algorithm. Okay, so then we'll get some digest value. So digest means it's a base 64 value. Like human cannot understand that particular message. Only public key holder can understand. So it's going to like encrypt that particular digest. And okay, same way in receiver side also. If you come to receiver side, so in sender side we have public key. Same way in receiver side we are going to have a private key. Okay, so it will take the incoming message again. Okay, again it will apply the decrypt key. Okay, and it's going to create again this one hash value. It's a digest B. So I can say digest A is from the client. Okay, what we got from the client. Digest B like what we generated in the server side. So then DataPower is going to compare these two values, digest A equals digest B. So if both are same, then I can say my message is safe. No one is modified my message. So that's how like we are going to implement cryptography. Okay, so yeah, so first we'll take the public key, then it's going to modify that particular. So it's going to encrypt that particular message. So we'll get an encrypted digest. Then we are going to get this from the receiver side. So we are going to use private key to decrypt particular message what we receive from the client. So that's how we are going to implement cryptography in DataPower. So this digital certification, so like you can sign your message. Like consider like you are getting some message, you can digitally sign your message. You can send it to the backend to verify that particular one. This is the use of cryptography functions in DataPower. So digital certificate is one thing. And you can also implement SSL handshake. Okay, so this is one of the like WS security implementation of DataPower, web service security implementation of DataPower. Okay, so how we are going to implement SSL handshake? Same way again, we are going to use same keys and certificates cryptography algorithm here. So we are going to implement this SSL handshake over here. Okay, this is a flow like how we are going to like this is the internal flow. So if you are exposing your web service over a HTTPS, that is like a secure connection. Okay, so if internally it's going to do all these transactions. Again, same here. Here also